Welcome to Learn with Roblox. In today's video, we're going to cover arithmetic sequences. Our first problem says we have 2, 7, 12, and 17, and that sequence will go on. And we need to find the 150th term. So I'm going to show you an intuitive way and then the formula that you can use. So I'll first start with the intuitive way you can think about this. So the first thing you need to do is see how much are we adding by each time. So from 2 to 7, 7 to 12, 12 to 17, how much are we adding by each time? Well, that's just plus 5 each time. So we're doing plus 5, plus 5, plus 5. And then we can say that this is the common difference. So the common difference, which you usually write as a D for these problems, is 5. So that's the first thing we need to know. Now what we need to do is realize that if we're going from, let's say 2 is the first term, and we want to get to the 150th term, we need to figure out how many times are we adding 5. Well, when we're going from the first term to the 150th term, all I need to do is 150 minus 1 equals 149. And that's how many times we're adding 5. So we're going to do plus 5, plus 5, plus 5, and we're going to do that 149 times because we're going from the first term to the 150th term. So now what we can do is we can do 149 times 5. Because to go from 2, which is our first term, to the 150th term, you're going to add 5 149 times. So if you do that, you should get that this is equal to 745. So to go from 2 to the 150th term, whatever that is, we need to add 745 total to it. So now, all you need to do is 2 plus 745 is equal to 747. And that is the value of the 150th term. So that's the intuitive way that I like to do this problem. Now let me show you the formula. This might be a bit easier for you. It's up to you which way you want to use. So here's the formula that might be useful to solve this problem. It says a of n is equal to a of 1 plus n minus 1 times d. So a of 1 is the first term, a of n is the term you want, n is the term you're looking for, and then d is the difference, the common difference. So we already know that d is 5. Oops. And then in this problem, we said that we want the 150th term. That goes into n. So let me just write that. So we have 150 minus 1 times 5. A of 1 is the first term, and the first term is 2. And we want to find the 150th term. So we can say a 150 like that. And then now this is it, which is an equation we can solve quickly. So 150 minus 1 is 145. And then we need to multiply that by 5. 145 times 5 is just 745. Then 2 plus 745 is just 747. And that is it. That's another way that you can solve this problem. So pick whichever method you like. In this problem, we have the sequence 7, 4, 1, negative 2 that continues on, and we need to find the 43rd term. So, like in the past problem, I'll show you the intuitive way that I like to do it, and then I'll show you the formula way of doing it, although they're both pretty similar. So I'll do the intuitive way first. So if we're going from 7, 4, 1 to negative 2, what's the change each time? Well, realize that to go from 7 to 4, you're subtracting 3. 4 to 1, that's minus 3. And 1 to negative 2, that's minus 3. So therefore, I can say that minus 3 is our common difference, d. And now here's the next thing that you want to realize. So 7 is our first term, right? So I'm going to say this is our first term. And you want to go to the 43rd term. So if we're going by minus 3 each time, and we're going from the first to the 43rd term, how many times are we doing minus 3? Well, all you need to do is 43 minus 1 equals 42. So in other words, we're doing this minus 3 42 times. And then to find what that total change would be, just do 42 times that we're doing that minus 3. So in other words, 42 times negative 3 tells us how much we change in total. So if you do 42 times negative 3, that is negative 126. So let me erase all this now. And all this is telling us is that to go from 7, our first term, to the 43rd term, we have to subtract 126 in total. So we start at 7, we subtract 126, and we get the 43rd term. So just do 7 minus 126. The answer is negative 119. And that is our answer to this problem. This is the 43rd term. And then now let me show you the formula way of doing it. So I'm just going to erase all this here. So to do the formula way, let me just write down the formula. The formula says a of n, which I'll actually replace this with 43, since that's what we want, is equal to a of 1, which is just 7, so we'll replace that, plus n minus 1 times d. And we know n is 43 because that's the term we want. And then d is just minus 3 as we found out. And as you'll see, it pretty much ends up being the same calculation as before. So this turns into 7 plus 43 minus 1 is 42 times negative 3. Order of operations states that we do the multiplication first. 42 times minus 3 is just negative 126. And then 7 plus negative 126 is equal to negative 119. So using both methods, we were able to get the same answer of negative 119. In this problem, we have the sequence negative 84, negative 68, negative 52, and it continues on. And we need to find the 29th term of the sequence. So I'm going to show you the intuitive way that I like to do it first. So first thing you need to do is find the common difference. So from negative 84 to negative 68, and from negative 68 to negative 52, how much are we moving each time? Well, here's what you can do. It might not be obvious, so what you can do is you can subtract two of the numbers, two consecutive numbers, and that'll be the common difference. So from negative 84 to negative 68, what you want to do is add the second, or take the second number, and then subtract the first number to find how much we're moving by each time. So you can do negative 68 minus negative 84. That's the same thing as plus a positive 84. And if you do negative 68 plus 84, that's positive 16. So in other words, we're adding 16 each time in this sequence. And you can verify this on your own, but from negative 68 to negative 52, that's also plus 16. So we're adding plus 16 each time. And then now, we know that 84 is the first term. And we're going to the 29th term. So from the first term to the 29th term, how many times are we adding plus 16? We'll just do 29 minus 1, which is 28. So we're adding 16 28 times. So to find out how much total we're adding, just do 28 times 16. And if you do 28 times 16, that's 448. So now, let me just erase all of this. So from 84, negative 84, to our 29th term, we have to add 448. So just do negative 84 plus 448, and that is equal to 364. So 364 is the 29th term of this sequence. And then now let me just show you how you can use the formula to get the same answer as me. So I'm just going to write the full formula. It says a of n is equal to a1 plus n minus 1 times d. So a of n, well, n is just 29. So I can put a 29 here. I can also put a 29 over there. Our common difference is just 16. And then our first term, a1, is just negative 84. And if we just solve this, you will find that we get the same answer. So let me quickly do it. You have negative 84 plus 29 minus 1 is 28 times 16. And then 28 times 16 is just equal to 448. And 448 plus negative 84 is equal to 364. The same answer that we got before. Now we have a new type of problem. So in this problem, we know that 4 is the third term of an arithmetic sequence, and 39 is the 8th term of an arithmetic sequence. Based on that, we need to find the 21st term and the first term. So first thing we need to do is find the common difference. How am I going to do that? The first thing we're going to do is find the difference between 4 and 39. How far apart are those two numbers? Well, if we do 39 minus 4, those numbers are 35 units apart. And then now, when you go from the third term to the 8th term, how many terms were in between those? Or how many times were we adding our common difference between the third term and the 8th term? Well, just do 8 minus 3, and that's 5. So basically, we were adding a number 5 times. So we're going to add 1, 2, 3, 4, 5 times. But what's the number we're adding? Well, think about it. We added a number 5 times, and then we moved 35 units in total. I'm going to write that up here. So the way that you can think about this is it's a simple division problem. So just do 35, because that's the distance we traveled, and we added a number 5 times, because from 3 to 8, that's a difference of 5 terms. So if we add 35 across 5 terms, well then each time we added, it must have been 35 divided by 5, which is just 7. So in other words, 7 is our common difference, and that's the first step to solving this problem. So now let me erase a bunch of this here. So now that we know that 7 is the common difference, we can find the first term and the 21st term. So here's how I'm going to do that. So I'm actually going to start with the 8th term and go to the 21st term. So from term 8 to term 21, how many times are we adding 7, our common difference? We'll just do 21 minus 8. 21 minus 8 is just 13. So we're adding this 7 13 times. So do 13 times 7 to get how much we jump from the 8th term to the 21st term. 13 times 7 is just 91. So to go from the 8th term to the 21st term, we just need to add 91. And we started on 39, so just add 91 to 39. So 39 plus 91 is equal to 130. So that is the 21st term. So I'm going to write that here. 130 is our 21st term. Then now let's find the first term. Now this one is a bit easier because we're going from the third term to the first term. And of course, the only other term that must be between those is the second term. So I'm just going to go from the third to the second, and then from the second to the first. And now be careful, because we're going backwards, we take our common difference of 7, and then we make it negative when we go backwards. So to go from the third term to the second term, you have to subtract 7, because we're going backwards, so you change the sign. And then from the second term to the first term, you also subtract 7 again, because we're going backwards. So we start at 4. 4 minus 7 is just negative 3. So negative 3 was our second term. And then do minus 3 minus 7 to get to our first term. That's negative 10. So therefore, our first term is just negative 10. Let me just clear all this up. And to write that. So our first term was equal to negative 10. And our 21st term was equal to 130. Let's go to the next one. In this problem, we have that the 36th term is negative 14, and the 49th term is negative 79, and we need to find the first term and the 63rd term of this arithmetic sequence. So to solve this, we need to first find the common difference and work from there. To find the common difference, first think about how far apart are 14 and negative 79. So in other words, how much did we travel when we went from negative 14 to negative 79? To find that distance, just do negative 79 minus negative 14. And if you do negative 79 minus negative 14, that's the same as adding positive 14. So negative 79 plus 14 is negative 65. So basically, to go from negative 14 to negative 79, you have to subtract 65. And then now, to go from the 36th term to the 49th term, how many terms do we add the common difference? Well, just do 49 minus 36. And if you do that, that's just 13. So in other words, the common difference, whatever that is, we added it 13 times to go from negative 14 to negative 79. So now let's set up a simple equation. If we traveled negative 65 units across 13 common additions, or 13 common differences, we'll just do negative 65 divided by 13. That gets you negative 5, which is equal to D, our common difference. So all I did was take how much we traveled to negative 65 and divide it by how many terms there were between 36 and 49, which is 13. And now we're ready to solve for the first term and the 63rd term. So I'll first start with the 63rd term, and I'll start from the 49th term. So to go from the 49th term to the 63rd term, how many times am I going to add this negative 5 common difference? Just do 63 minus 49. If you do 63 minus 49, you should get that we add the common difference 14 times. So just do 14 times negative 5 to get the total amount that we jump from 79 or negative 79 to the 63rd term. And that's negative 70. So let me just write this. So to go from negative 79 to the 63rd term, you have to subtract 70. And now just do negative 79 minus 70, because that's what I said we're going to do. And if you do that, that is equal to negative 149. Therefore, the 63rd term is just negative 149. And we're done with that part. Now let's go in the other direction. We need to find the first term. I'm going to use the 36th term as a starting point. So to go from the 36th term to the first term, how many times are we going to add, or in this case actually subtract, the common difference? Well, 36 to the first term, just do 36 minus 1, and that's 35. So that's 35 times that we subtract the common difference. And I say subtract now because we're going in reverse. So now we just need to do 35 and then times. The common difference was minus 5, but because we're going backwards from 36th term to the first term, we have to make the common difference a plus 5 now. So 35 times 5 is simply equal to 175. So to go from the 36th term to the first term, you have to add 175 instead of doing negative 175 because we're going backwards. And now just go from negative 14 to the first term by adding 175. And if you do that, you'll get that it is equal to 161. So the first term was simply equal to 161. And just like that, we're done. In this problem, we have that the 8th term is 6 and the 18th term is 10, and we need to find the first term and the 200th term based off of that. So we first need to find the common difference, d. And the common difference will be equal to the difference between 6 and 10, which is just plus 4, divided by the number of common differences that we add from the 8th term to the 18th term. And how many times do we add from the 8th term to the 18th term? Just do 18 minus 8, which is just 10. So basically, across 10 additions of the common difference, we only went up by 4 units. Therefore, the common difference is just 4 divided by 10, which is equal to 0.4. And now we found the common difference. We're ready to find the 200th term and the first term. So I'll start with the 200th term. So to find the 200th term, I'll start from the 18th term, and we're going to go to the 200th term. How many times am I going to add the common difference? I'm just going to add it 200 minus 18, which is 182 times. So if I'm adding points for 182 times, I can just find that total distance that we changed by doing 182 times 0.4. And this is equal to 72.8. So to go from 10 to the 200th term, because 10 is our starting point, we just have to add 72.8. So then if we do 10 plus 72.8, this is simply equal to 82.8. So the 200th term is simply 82.8. So we found that out now. And now let's find the first term. So to go from the 8th term to the first term, notice that there's 7 terms in between that, because 8 minus 1 is equal to 7. But now, instead of doing 7 times plus 0.4, we're going backwards. So change that 0.04 common difference to a negative 0.04. You have to flip the sign if we're going backwards. So do 7 times negative 0.4 to find the change from the 8th term to the first term. And 7 times minus 0.4 is negative 2.8. And now, to go from 6, which is the 8th term, to whatever the first term is, we just need to subtract 2.8, or do negative 2.8. And then now, just do 6 minus 2.8. And if you do that, you should get 3.2. So therefore, our first term is just 3.2. That's it. We're done with this problem. If you enjoyed the video, please like and subscribe. Thank you for watching.